Hello, today we're going to complete the scale drawing review on lesson 2. So this was the first page that we started yesterday together, and now what I'd like you to do is turn to the back page. Today we're going to find the scale factor, in other words, the scale. So let's start by using our first example. A man in a photograph is 2 centimeters tall. His actual height is 1 8/10 meters. What is the scale factor? Well, let's go ahead and highlight that information. You may have noticed that they didn't give us a scale like we on the other problems that we did. They said 2 inches equals 5 feet. Well, in this case, they did not give us a scale, so we're going to find the scale factor. And what we're looking for is 1 centimeter equals what of the actual. In this case, it's measured in meters. So that's what we're looking for. And you're going to notice that it says 1 centimeter. So in other words, we can kind of look at the scale factor as a unit rate. In fact, when we use the equation method, we are indeed finding the unit rate. So for instance, I would look at the model as my x value and the actual as my y value. So when you find a unit rate, you use y divided by x. Now I'm going to choose a proportion to set this up because I think the labels will make it a little bit more clear. So in order to make this unit rate, I'm going to take the actual, which we're using as our y value, and we're given 1 8/10 meters for the man's actual height. And then we're going to talk about the model, or in this case it's a photograph. He is 2 centimeters tall in the photograph. So if I'm trying to find the unit rate, I'm trying to figure out how many meters the actual measurement is for 1 centimeter. If I'm trying to find a unit rate, unit means the amount for 1. And we've already set up knowing that the scale factor is 1 centimeter for however many meters. So if we cross multiply, 2 times x would be 2x, and 1 8/10 times 1 would be 1 8/10. We're going to divide, and when we divide, we get x equals 0 9/10. So the reason I chose to do proportions instead of the traditional way is now I have my label here. If I didn't set this part up initially, now I know that what I found is 0 9/10 meters. Another shortcut to find this scale factor, as long as you start with the actual. So if I took the actual measurement is 1 8/10 and just divide it by the model measurement, which is 2, we get the same number, 0 9/10. However, I think the proportion makes it a little bit more clear since we're labeling our measurements. And we could actually do that here. We could label those measurements. Whatever we find is this measurement for one of this measurement. So we could use this to write the scale, but also if we use it in this form, if you recall the other day, we talked about a method where we took the rate, which is what we just found, times the model measurement, and that gave us the actual measurement. So that gives us the ability, when we write it like this, to use it in the equation. So let's check it out and see if it actually works. If I used the rate as 0 9/10, and I took it times the measurement that they happened to give us in the model, which was 2 centimeters, that would be 1.8 meters. So we just want to make sure that we include our units of measure when we're doing this. So now let's try letter D. An 80-foot long driveway is just 7 inches on a scale drawing. What is the scale factor for the model? So let's recall that scale factor, they're asking us to find the unit rate or I want one of the model measurement, so the model must be 7 inches, for however many of the actual. So this must be, if I look at this appears because it says 84 feet, this must be the actual, and it says 84-foot long driveway is just 7 inches on a scale drawing. So now we're clear on that. So here's what we're looking for. We're looking for 1 inch equals a determined amount of feet. So that's what the scale factor, that's what we're looking for. And we also mentioned that scale factor is the same thing as a unit rate. So I'm going to start by setting up a proportion. I'm going to put the real, which is 84 feet, the actual, over the model, which is inches. And I want to know how many feet. I'm going to label that to help myself. For 1 inch, we're finding the unit rate. So now we're going to cross multiply. And so that would be 7 times x equals, and we're going to cross multiply on that side. That would be 84 times 1. So that would be 84. And then when we go to solve, we're going to divide by 7 on both sides. And you can probably already see that this is what we started with, and this is what we're going to solve. And so the shortcut is to just take 84 divided by 7. The reason I've chosen to use the proportion, though, is because the labels make it a little bit more clear what we're finding. And the answer is 12, and if I look up here, I know this is 12 feet. We also helped ourselves out by acknowledging that the scale factor is really the scale for 1, and so we've labeled that. Either way, this is 12 feet. So 1 inch on the scale drawing represents 12 feet. So if you're just asked to find the scale factor, we are now finished. In letter C, I chose to show you how we could extend the use of the scale factor with the equation. So at this point, let's try practicing this on our attached paper. Thank you.